Welcome to the fourth lesson in Session 1 on evaluating logarithms. To evaluate logarithms, we need to learn a method of solving exponential equations when a common base exists. So to solve an exponential equation with a common base, the first thing we need to do is express the left side and the right side of the equation using that common base. Once we've set up the left side and the right side with the equivalent bases, we can then drop the base and set the exponents equal to each other. Once we have the exponents equal to each other, we can then solve the equation. So for example, we're going to solve these equations without using a calculator. So we have 3 to the x is equal to 27. Now many of you may be able to look at this and understand what the value of x is based on your knowledge of exponents. But here we're going to learn a method. Now notice the left side of the equation is already expressed using a base of 3. 3 to the x power. So the base is 3. So my goal is to express the right side of the equation using a base 3. It just so happens that 27 is a number of base 3, and that's 3 to the third power. So now I rewrite the right side of the equation. Instead of 27, I express it as 3 to the third power. So now I have the left side at 3 to the x equal to the right side, 3 to the third power, using the exact same base. Once I've expressed the left side and the right side of the equation using a common base, I can drop the bases altogether and simply go with the exponents. So in this case, we have the result x is equal to 3. As you'll see in the next example, the same thing holds. The left side is 2 to the x power, and the right side is 16. Now the left side of a base 2, I can't get anything smaller than a base 2, being that it's a prime number. So I look to express the right side of the equation as a base 2. And it just so happens that 2 to the fourth power is equal to 16. Once I have the left side and the right side expressed using the exact same base, I can then drop the base and go with the exponents, and I get x is equal to 4. In the last example on this side, I have 4 to the x power equal to 8. So the left side is expressed using a base 4. However, the right side of the equation cannot be expressed using a base 4. In that case, I look to go smaller. Can I break down the left side even further? And it just so happens that we can. 4 is the same as 2 to the second power, and 8 is the same as 2 to the third power. So I can express the left side of the equation and the right side of the equation using a base 2. So the left side becomes 2 to the second to the x, and the right side becomes 2 to the third. Now using the power property of exponents, the left side simplifies to 2 to the 2x power equal to 2 to the third power. And as we drop the base, I'm left with 2x is equal to 3, leaving me with a one-step equation to get to my answer, and x is equal to 3 over 2. As we continue to evaluate logarithms, the way we start is we set the expression equal to x. So we'll be given an expression, and we need to turn it into an equation for x that we're going to solve. It can be any variable. We're going to choose x for this lesson. After we've set the expression equal to x, we then need to translate the logarithm into exponential form, where we're then going to solve the equation using the method that we just learned. So here I have an expression, log base 2 of 16. So to evaluate this expression, the first thing we need to do is set it equal to x. Once I have it equal to x, I can then rewrite the equation in exponential form. I get 2 to the x power is equal to 16. Now I manipulate the right side of the equation to identify a common base. 16 is equal to 2 to the fourth power, and I get an answer of 4. So log base 2 of 16 is equal to 4. And that's how we evaluate logarithms. Again, another example, log base 8 of 8. So we start by setting the expression equal to x. Then I translate 8 to the x power is equal to 8. Solving that equation gives me x equal to 1. In our last example, I have log base 9 of 1/3. So first thing we do is set it equal to x. Then I translate. 9 to the x power is equal to 1/3. Now the left side and the right side can both be expressed using a base 3. 9 is a base 3, is 3 to the second, so that's going to give me 3 to the 2x. And 1/3 is a base 3, is 3 to the -1. So once we get equivalent bases, we drop the base and we go with the exponents. 2x equals -1, which gives me an answer of -1/2. So that concludes our lesson on evaluating logarithms. Feel free to email us if you have any questions, and good luck on the quiz.